Solve problem 10.1. Sphere rolling down an inclined plane. A solid sphere with a mass of 5.15 kg and a radius of 0.340 meter starts from rest at a height of 2.10 meter above the base of an inclined plane and rolls down without sliding under the influence of gravity. What is the linear speed of the center of mass of the sphere just as it leaves the incline and rolls into a horizontal surface? So here in this question, you have a solid sphere that has a mass m of 5.15 kilogram and a radius r of 0.340 meter, and it is initially at rest, so v initial will be equal to 0. Then it rolls down an incline from a height h of 0.340 meter. We need to find what is the linear speed of the center of mass as it rolls down from the inclined onto the horizontal surface. So we need to find the final velocity at the bottom. We are going to use the law of conservation of mechanical energy to solve this problem. We will take 2 points in motion to use this law. One will be the top position, the other will be the bottom. We know from the law of conservation of mechanical energy, total mechanical energy at the top is equal to total mechanical energy at the bottom. Total mechanical energy can be written as sum of kinetic energy plus potential energy. We do the same thing for energy at bottom, kinetic plus potential. Now kinetic energy at the top will be 0 since the sphere was initially at rest. So its velocity is 0 and hence the kinetic energy is 0. Potential energy at the bottom will be 0 because at the bottom the sphere is not raised at any height, so it has no gravitational potential energy. So you are left with potential energy at the top to be equal to kinetic energy at the bottom. Now kinetic energy at the bottom is the sum of translational kinetic energy and rotational kinetic energy. So now let's substitute the rule for each of them. Potential energy is mgh. Translational kinetic energy will be half mv squared and rotational kinetic energy is half I omega squared. Now I is the moment of inertia of the solid sphere, and as a general rule you can write moment of inertia to be equal to cmr squared. Omega can be written as v over r. So let's substitute that here. I get mgh to be equal to half mv squared plus half. In place of I will write cmr squared. Omega squared will be v squared over r squared. Now let's cancel off the common terms. We can cancel off the m's here, r squared and r squared. Then we are left with g times h to be equal to v squared by 2 plus cv squared by 2. Now let's take v squared by 2 common. V squared by 2, and then you are left with 1 plus c. I need to find what is v, so we will rearrange this term to write in terms of v squared. I'm going to multiply with 2 and divide with 1 plus c. So we get v squared to be equal to 2gh over 1 plus c, or v to be equal to square root 2gh over 1 plus c. Now we can substitute the values to calculate the velocity v. This is the general rule for the linear speed of center of mass at the bottom whenever an object is rolling down the incline. All you have to do is change the value of c with the object. So for a solid sphere, c will be 2 over 5. If you had a hollow sphere, the c will be 2 over 3. Whereas for a cylinder, the c will be 1 over 2. So depending on what object is rolling down the incline, you can change just the value of c. The rest of the velocity expression remains the same. So now let's substitute. We get square root 2 times g is 9.81, h is 2.10 over 1 plus c, which is 2 over 5. And then you get v to be equal to 5.42 meter per second. So this is the linear speed of the center of mass of the solid sphere as it leaves the incline and rolls onto the horizontal surface.